is another really good friend of mine. He's got a new nickname, and we gave it to him yesterday. But I'm not going to give you any context. I'm going to keep you like hanging on your seats, so I might mention it later on. But no, seriously, in all seriousness, Cory is an amazing guy. Knowing Cory for, again, quite a long time. He's a staple inside of this industry. He's worked on a tremendous amount of events throughout the entire world. He's definitely one of the leading media server and video technologists inside of this industry. So, Cory, welcome to the plate.
I don't live up to any of that hype. He's just fluffing me up. I'm Cory, right. So I'm Cory. Right, exactly. This title is kind of a misnomer. I really kind of despise talking about engineering because I think it always comes off a little bit preachy, you know, like this is the way and you must do it this way. So I kind of thought for this, it might be a little more interesting to look at two different shows that have very similar infrastructure, same platforms, but had to use those tools in very different ways to achieve the end results. The first one, which we kind of saw some videos of in AJ's presentation, is at the Houston Museum of Natural Science called Energy City. We'll look at some videos on these in a second, but I thought this was a good one because it's really the embodiment of what an engineer loves. I love having complete control in this little bubble. You know, like I want to eat off the floor. It's so clean. And everything can be dictated to achieve the client's results, from content templates through playback through programming. We had 2.5, 3 years to get this project off the ground. So we could literally build custom software. We ended up writing a completely bespoke automated alignment system that did not use any cameras, which was interesting. It didn't end up working. It worked. You just, scanning a model is really important. Oops. And the other one we're going to look at is a show called Limitless AI, which is another immersive project everywhere show in Brooklyn. It was the first installation at a 5-year residency that kind of Van Gogh-ish, but they're going to rotate through artists every 8 months, 9 months, and it was not a clean room at all. They went through several production companies, several different teams of people designing projection layouts and doing all the studies and the server integrations, and none of them were there. And they kind of Googled projection mapping company and found RabCup. And AJ, bless him, called me and said, "Hey, do you want to go to New York next week and do an 80 projector show?" Sure, why not? Maybe not the best decision, but it really wasn't that bad. It was very last minute. It was very under budgeted, but it sounded like a fun challenge, and I had an opening on my calendar, and AJ wanted to do it too. So complicating everything, it was designed by committee. So there were 9 designers and producers, and the key stakeholders were not present. So everyone had a different idea of how this was going to go, and what it should look like, and what it should do. And just because there's not enough fuel on that fire, the opening designer was only going to be there for 6 days. So again, these two shows I thought were interesting because they use the same platform. They were both Hippo shows. The system design ended up being very similar between the two. A team out of Chicago did the original system design, and it's always like validating when you look at someone's drawings and you're like, oh, that's exactly how I would have done that, and how we did do it in Houston. So it's interesting to compare them that way. The show flow ended up being roughly the same. We didn't know that in New York when we got there. We thought it was going to be just super simple, straight playback. Nope, hard pass on straight playback. But we had the right tools in place to pivot really quickly and kind of use those tools in different ways to end up with a 160-layer show. The programming requirements were very different, as we kind of just talked about. And day to day, they were very different in operation. Similar but different. Like at the end of the day, there were no technical people operating these venues. They wanted an iPad and press a button, and the show runs itself. I think the most technical thing in Brooklyn was someone had to hold a dead man switch for automation. So it's always fun when you get these tech shows and no one thinks that they're complicated at all. But we can kind of look at Energy City to start. The quality of this video is not so great. The only day we could get a video guy was while we were blending. So a little pre-blend. Energy City at the time, I think, was the most complicated projection mapping project undertaken. It was 17 million polygons, which if you're used to playing in game engines or anything 3D is a lot. And we were wrapping content around that in real time, straight to UVs, no model simplification at all. So it was 32 9,000 lumen projectors at 1920 1200. I mentioned the cameraless auto alignment system. 9 6 output boxes. One was a spare, 8 active. We could only use 4 of the outputs because the load was so heavy trying to deal with this model. It was about 130 megapixels across 7 delivery templates, which we'll kind of look at as well. The final content load ended up being somewhere around 7 terabytes for 30 minutes. And then we get limitless AI. Project on the walls, project on the floor, cylinder in the middle. This ended up being 73 projectors by the time we were all done, 11,000 lumen, 1920 1200. Content in this case was done very differently. It was done per wall. When we got the drawings, they're like, we don't know how this fits in the space. You're gonna have to just squish things around and hopefully make it line up. Yeah, we'll look at those awesome drawings too. But the assumption was, you know, circles don't have to be circles. You can literally just pin the corners to the walls and run with it. First thing I think is good to look at is projection studies. Energy City, obviously, there were a lot of considerations with all those buildings. It was like 1,600 individual buildings that all had to be mapped 270 degrees. People could walk around this whole thing. For scale, that's 85 feet across. And we knew pixel density was going to be a problem. You know, these curbs in scale were 1 millimeter tall. We don't have 1 millimeter pixels here. We're sitting around 5 millimeters. We wanted to do 4K projectors and everything like that. But 5 years ago, the technology wasn't there. It would have been a ridiculous amount of processing to deal with that. But it was a unique challenge to figure out, like, how do you do a projection study on something with so many occlusions and so many little details? And I kind of went back to my lighting design days and thought of it like a light plot. So this would be like your psych system. We had a set of front light systems that ended up being like downstage fronts and upstage fronts. We had side lights from stage right, from stage left. And we kind of used the tools in Shape, which is Hippo's 3D mapping plugin, to look at the blends and make sure we didn't have any massive holes. And then we could go through and look at, like, straight down the lens, exactly what every projector sees, see if there's any weird occlusions, if we're going to hit sprinkler pipes, another projector. There wasn't a ton of ceiling space on this project. So we were literally moving projectors digitally to move the lens 1 inch out of the cone of another projector. There was a lot of sprinkler pipes, which you'll see here in a minute. But, you know, the nice part is going back to previs, we could account for all of that ahead of time. We could tell the content company, like, hey, don't put any text like in the top 11 inches of the screen because you're probably going to have a mask there. Because it was in this super sterile clean room kind of environment, we could get really granular on where projectors needed to go, exactly how much they had to tilt. We were putting levels on these things because moving the projector 2 inches or tilting it an extra degree and a half, you'd magically have a shadow on the back of a building that you don't want a shadow on. So like the integration company that had to hang all the projectors was like, does it need to be 7.6 degrees? It's like, yes, it does. Absolutely. Limitless AI, on the other hand, that was the drawing that I got, which is not a drawing. But someone had made a model, and someone had not UV mapped a model and just kind of projectively textured the model with the templates, assuming that, again, we were just going to squeeze things around. So the original projection design called for 4mm pixel pitch, and they kind of just said, we're going to go for the middle of the lens, and wherever you guys hang them is where they're going to go, which is fun. Very fun. The cylinder had a bit of a curveball on it. It was automated and it would open up to reveal a band that was wearing EEG brainwave trackers. And there was a whole live portion that was like an 11K by 6K NDI stream. Went to all the different servers and multicasting, and you could see their brainwaves on the walls. And they were also tracking everyone's heartbeat. So immersive, edgy. The projection study that I was given looked like this. Center of the lens, here's some pixels, and go for it, which was enough to kind of figure out what was happening, but not enough to plan ahead and say, all right, how are we going to go about this? It was kind of just show up on site, run and gun, hope all the tools are there. So when we start looking at the engineering side of it, we have a nice system in Houston. This is the video riser. Pretty straightforward, right? It's like servers go DVI into the router spits fiber out and spits out a multi-view. So the multi-view is nice, right? Because we had 2 years of projectors in the air. Couldn't do anything with the projectors because they were building a model. So we could still program the show ahead of time using the multi-viewer and kind of get some of the legwork done. The networking side was also pretty clean. To keep things easy for the day-to-day, like maintenance staff at the museum, who were not technical video people at all, we went with completely separate, isolated networks. Getting into VLANs and stuff was just going to be difficult for them to maintain and change over time. Timecode, genlock, all the basic things to keep things running in sync and to keep things happy. You know, we could really design this system to be exactly what we needed it to be and only what we needed it to be without unnecessary bells and whistles. And wire specs, always important. You can no longer just say, I need DVI or I need HDMI. So we could call out everything and be ready and have all the tools there. And this is the riser diagram for limitless AI. It's a little less detailed. It's really kind of a flow chart, not really a riser diagram, but it was the same idea, right? We had servers going to FX4s. We had between 10 and 15 projectors per server. That went into a router, and it went out HDBaseT. So same on the general signal flow, and that workflow ended up really saving us trying to figure out how to squish all these things together. And also not shown on this drawing is 2 high-spec box computers that did the NDI stream at 11K by 6K. Part of the trick with Energy City was managing the content workflow and how do you play back these crazy resolutions on a 3D model without taking 3 years to render. And so we really kind of spent a lot of time building a very granular media delivery spec, you know, how we're going to receive deliveries. We're not going to rely on internet. It needs to be hard drives. It needs to be this specific codec that's performance optimized for wrapping around this model, right? It needs to be this exact resolution, this frame rate, this color space, because we were literally at the edge of what these machines could do. File naming, super important. And then this is kind of what those delivery templates look like. If you're familiar with UV mapping, you'll know that this is just an automatic unwrap. There's not a lot of thought into it because everything had to be done in 3D. So some of the buildings we kind of pelted a little bit to make it easy to paint in like warning lights, but for the most part, it was just squeeze it into the raster. Some of it got really hard to manage when you're like, that building right there is the wrong shade of pink. And they're like, where is that on the raster? And it's like, one of them. Limitless, on the other hand, was just walls. Literally just content for each wall. And they said going into it that we don't know how tall the walls are going to be. Like, we might put a trim line at the bottom. We might go all the way to the ceiling. We might project through the grid. If we like it, we'll keep it high. So we did everything at the full height of the projector raster, knowing that like the key areas are where you see the colored boxes. But everything was rendered with headroom for variable height, which also meant that we could get a little more friendly in squeezing it in and keep squares square and circles circular by kind of undersampling the content. The control and programming side is always difficult to get images of. I'm very bad at like taking screenshots of consoles. But they both operated on the assumption that show control was going to drive everything. So in Houston, we had a Crestron CP3, little touch panel on the rack, and that did monitoring, did control of the projectors, the servers, tied into the fire alarm, and literally they just wanted like start day. Sounds super simple, but when there's 11 servers and 32 projectors and a whole audio system, it's not. So building that logic in through really what's just TCP strings and kind of building a system that a docent, who's probably someone's grandmother, can run this whole system by herself and reorganize the show and say, today we've got a guest from oil company X. We probably shouldn't show nuclear power. We should only show hydrocarbons. It's really what they wanted. Like, they wanted a drag and drop kind of playlist creator, which is a really tricky thing to do when you don't have headroom for crossfades, and you have to really think about how to program in a non-linear way so that everything feels seamless and kind of not on the fly. Which was kind of the same thing at Limitless AI. So we went into it thinking it was going to be straight playback, play this layer, let it loop, it's going to be great. When the artist showed up, he said, I hate how all of this looks. Can you take one file and slice it up in the box? So away went the templates, and we had one roughly 8K video, 8 layers per surface, and we literally put all the like hippo effects, like sliding and slicing and resampling on the fly in the box. So I ended up pulling in a lighting console for that because there was no way I was going to keyframe all of that ever. I would have been there for, well, I'd still be there. So that was a really quick pivot to try and put this whole show on DMX. We ended up with, I think it was 31,000 parameters. So MA was very happy to make that sale, as was Alcorn McBride, which ended up doing the show control on this project, tying in with Crestron and the 8 moving lights in the space and 73 projectors and the audio system, which was this crazy audio system. I don't do audio. I think it's like voodoo dark magic, but they had more audio channels than projectors. So we'll put it that way. Fire alarm triggers with no lights in the space. The fire alarm or the fire scene had to be projection, which is very rare. Normally, I'm used to fire marshals saying, like, just turn them off. I don't want to see them. Here we had to do everything in solid white. Like, highlight the exit signs, which was its own queue, very special queue. But V16, Alcorn McBride, ended up running all of that on an iPad so that an intern could walk over and say, yep, no one's going to get killed by the automation. Go ahead, start the show. And then 3 days before it opened, they said, the show's too long. We want to dynamically adjust the length of every chapter. Back to the MA, back to show control, and we built essentially in Lua and in macros, we wrote a sequence by which they can say chapter 1 is going to be 4 minutes today. It's going to be 7 minutes tomorrow. We're skipping chapter 3. The band didn't show up, so we're not doing a live section. And again, this whole nonlinear way of going about programming that would not have been possible if it was truly designed for straight playback, right? I mean, I don't really think there is a right tool, like a right media server. I think whatever server you know is the right choice. But I really don't know how this could have happened on any other server. Mainly because DMX, you have to be really really careful on how you're programming these shows that end up being nonlinear when you think they're going to be linear. It is a documentation nightmare. But outside of that, it ended up working. So that's it.
Wow.
Super quick. I could not be up here. Any questions? Yes.
So when you're making the model for Energy City, or I guess the question is more, who makes that model? Is there someone on the content side that's making that model? Is it a collaboration?
It ended up being a collaboration. The museum exhibit design company made the first model because everything was going to be CNC'd and 3D printed. They had a lot of the problems that we end up with models, right, where vertices overlap and like what should be a single vertex is two, and you end up with these like non-planar faces. So we ended up spending a lot of time cleaning it up and going through and saying, you don't have a seam where this window is, like you're missing geometry or you have too much geometry. So they did the heavy lifting and we just did the cleanup for the most part.
And then follow-up question, did you all then take that, unwrap, and give it to the content?
Yeah,
cleaned it up,
exactly. Yeah, we had a little bit of dialogue with them, obviously on like, can we really just automatically unwrap everything? Which is why some of the buildings ended up pelted, because there were some things that are like, I don't want to like model the helicopter light in 3D, like with a traditional texture. Like I just want to put a flashing red thing in After Effects. But like that wasn't going to be possible for every single house. So pelted. It's what Studio Max calls it. Yeah, so I mean, it generally, right, it's choosing a vertex to unfold across, right? So like skinning an animal, I think is why they call it pelting, right? You just pick a line, and if you've ever seen like the face that's totally flattened out, same idea.
The other thing you can do with pelt mapping, just to say it, the other thing you can do with pelt mapping is you can assign one area of your raster to multiple places on a 3D model that you can't do with just a regular UV unwrap. So standard UV unwrap, like everything has to wrap specifically to that object. With a pelt map, you can say, I want to pull this thing for the lights every time. Right. All of the things that are this area can be, everything else. It's a different way of doing it.
Yeah. Cool. Oh, yeah.
You talk a little bit more about limitless AI, like the choice of using programming for automation, or I guess to do that, and for I guess like for like people that aren't land designers. I mean, what other tools would you be able to get through something
Yeah. So yeah, so the question was kind of why a lighting console in this case, and were there any other options? I was a lighting guy to start, so I am comfortable on a lighting desk. I think it's a lot faster than timelining for someone who's not a content creator. I think timelines are, for me at least, they're very slow and like one layer, one parameter at a time. Whereas on a lighting desk, I can say, take every layer one on every box and put it in this clip and make it a little more contrast and store cue done. So when we ended up with, it ended up being, I think it was like 133 layers, trying to like multi-edit and save these cues, this immense number of cues to re-chop the entire show. I needed something that I could do more than one thing at a time with. So for me, that's always a lighting desk. With where my comfort is in programming, I'm sure there's people who could have done amazing things with OSC or MIDI controllers or probably even Stream Decks at this point. It's kind of just whatever tool you think is going to make you more efficient.
Never thought of like bringing in a lighting designer to anything in a project that doesn't necessarily call for lighting fixtures.
Right.
But it seems like that is the tool to get this, like like you're saying, selecting a bunch of layers, same parameters or whatever. Jogging, like there's really not another way to go.
Yeah, I mean, on the live event side, a lot of media server shows are driven by a lighting console. I'm not sure really why that ended up being that way. I think it's when the DL series from High End came out, it was the lighting guy's job to do the video, and then it split apart, and now it's kind of slowly coming back together. So, um, people didn't need to buy dedicated hardware to control this black box that spat out pixels. They had it in their rental inventory.
We also blame it on the evolution of media servers.
Yeah, you could. Well, it all went back to the Icon M, right?
Yep, Icon and how it's
Blame Nick Jackson. Uh, yeah, so I mean, it's not necessarily the best way to control a media server, but it is a way, and it is a very common way. And I think it's always good to have some lighting programming knowledge in your back pocket when you start dealing with media servers in general. Cool.
All right.
Oh, just drop it.